Okay, hello guys. So this is my next video. Now we want to find the value of a, b and c, a constant in our partial fraction. So in order to do that, we are going to bring all the denominator on your left hand side to the other side. So we are going to get here 3x to the power of 2 plus with 7x plus with 28. Since we are going to bring all the denominator that we have here to the other side, so you are going to get here a over x multiply with x, and you are supposed to multiply it with x squared plus x plus with 7. And here we have another fraction, so again there's another multiplication that we need to do now. So we are going to get x squared plus x plus 7 multiply with, you can put a bracket for each of the factor that we have, multiply by x multiply by x squared plus x plus 7. Since here we are dealing with multiplication, and this part also we are going to deal with the multiplication, so basically we can try to cut it off for the same factor, which is x divided by x. We are supposed to get 1 here, and another factor, the quadratic factor here, divide by these two, the same element, so you are supposed to get the value of 1. And we can get a new line here, which is 3x squared plus 7x plus with 28 equals to a x squared plus with x plus with 7, which is our quadratic function, plus with bx plus c, a factor multiplied by our quadratic, our linear factor. So in order for us to use the Heaviside method, so basically we need to find where the possible value of x can be substituted so that you can get a 0 for this factor. So now look, it is impossible for us to use a real value in order for us to get 0 here. But here, for the value of x, basically we can make it 0 by replace it into 0. So what we can see here, we can name this one as equation number 1. So you can see that here we are going to substitute x equals to 0, supposed to be x, into equation number 1. So you are going to get here 3 times 0 is supposed to be 0, 7 times 0 will be another 0, so it will be 28 on your left hand side. Here also, if you put 0 for the x squared, you are going to get 0. X here, if you replace it with 0, again another 0 will appear. So 7 plus 0 plus 0, so it will be 7a. And if you put 0 here, so basically you are going to get 0 multiplied with 0 plus c, so 0 plus c will be c, c multiplied by 0, so of course you are going to get 0 for this part. So you are going to get 0. So here you are going to plus it with 0, so no need to write the 0b there. So we are going to get with 28 equals to 7, which is the value of a is equals to 28 divided by 7, which is a equals to 4. So how about to find the value of a here? It should be, the value of b and c now. It's a big problem because now the factor of our quadratic will never be 0. So basically we cannot rely so much on substituting the value of x. So what we are supposed to do now, we are going to use another method. We call it as a comparing coefficient method. So now let us save this value, which is we already know that the value of A is equals to 4. Because we already do the calculation here, so I need to erase it because I need to have some space here. So let me erase all this. Okay, now let us just focus on the part of equation number 1 here. So as we can see here, and also this part, we can actually expand the equation that we have here by using a multiplication. So we can multiply the A with x squared, A with x, and A with 7. So this part also you can do the same method, which is you are going to multiply it one by one, which is you can multiply the bx and x, c and x there. So if we try to expand it, we are going to get the left hand side will be the same value there, but here we are going to get ax squared plus with ax plus with 7a plus with bx squared plus with cx. Then rearrange this part. Okay, let me put it our notes. We need to rearrange, which we are going to put the highest power into the first part, and then the second lowest, and also the lowest value of your x there. So you are going to get here 3x squared plus with 7x plus with 28. It's supposed to be, you have the same variable here, which is x power of 2 and x power of 2. So you can combine it, which is you are going to get here a plus with b, which is you have the common factor of this, which is x squared. And you have ax here and cx here, so it will be plus with a plus c and x. So here there's a single constant without any variable, so it's supposed to be 7e. Then we can do the comparing coefficient method. So we are going to compare the coefficient. So in order for us to do the comparing, basically we need to have two sides. So this is your first side, which is left hand side, and this is your right hand side. As we can do a comparison here, this is a group of x squared, which is you can compare with a group of x squared here. A group of x power of 1 with a group of x power of 1, and a group without variable 28 and 7e. So you can do the comparison now, which is we are going to get here 3 is equals to a plus b, because you have the common variable there as well. And another comparison that you can do here is a plus cx. So you get here 7, so it will be a plus c is equals to 7, and 7a is equals to 28. So basically we have done this calculation, which is we already know that the value of a is equals to 4, because 28 divided by 7 is supposed to be 4. Then we can replace the value of a here with 4, so it will be 4 plus c equals to 7. Then you can say that the value of your c is equals to 7 minus 4, which is 3. And the value of a we already know, which is 4 plus b. So the value of b is supposed to be 3 minus 4 will be negative 1. So we already get all the value, which is a equals to 4, b equals to negative 1, and c equals to 3. So what we need to do next is we are going to replace the value of A, B, and C here in our partial fraction. So since I don't have any space here, let me erase or try to clear this part. Okay, we already get the value of A is equals to 4, so it will be 4 over 3, sorry, 4 over x. 4 over x plus with b is negative 1 multiplied by x, so you are supposed to get here minus x plus c, so c is positive 3 over x squared plus x plus with 7. So here this is the value of your partial fraction. Okay, so which is, you can see that the same value here can be put into a small fraction, which is, you can put it into two fractions, which is will give you the same value, which is 4 over x minus with x plus 3 over 4 over x, and also minus with x plus 3, x squared plus x plus 7. So you can replace it into 4 over x minus with x over x squared plus x plus 7 plus with 3 over x squared plus x plus 7. Okay, let me stop there. Since I don't have any question regarding integration, so you can just stop there. So if I have integration part there, we need to integrate all each of the equation that we have here. So I stop now because we are going to see another example on question 9.